Hi and welcome to part 3 of our video series where we're having a look at the GAGE framework and breaking down how it works, how it's structured. This particular episode, if you want to put it that way, we're going to have a look at graphics, in particular how it's set up and structured to actually draw things. Now there's a fair amount to this, and because of that we're actually going to split this into 2 separate videos. In the first one, we'll just have a look at Android in general in terms of some of the ways that we can draw to things and the setup that we're assuming for this particular module. And in the second bit, we'll delve into a little bit more detail in terms of how we can do this fast. It'll involve a little bit of threading, and then we'll explore the actual code itself within GAGE in terms of seeing how it is looked at. But for the first video, it is very much introductory. So we'll start off now exploring some different aspects. Now, first thing we can say, this is really by way of context, because if we're thinking about graphics, it's a truly massive area. There's many things that could be covered on it. So very much this is going to sort of paint a very broad picture, but very quickly we're going to narrow things down to say that in the context of this module, in the context of GAGE, this is the specific thing that we're looking at. So very much it's just narrowing your expectations down. First thing, when we think about rendering or drawing games. Games, you could crudely characterize them as 2D and 3D. And again, there's been a direction of travel, sort of the old style games were more 2D, nowadays it's more or less all 3D. We're really just interested in 2D games. So when we're thinking here about drawing or graphics, it really just is 2D that we are concerned about. We're not looking at 3D and the related aspects about that. It's a fascinating area, but it's beyond the scope of this particular module. Okay, so if we're thinking about 2D rendering and what that actually means, it's actually fairly straightforward. In essence, for a 2D game, if we're drawing the world to the screen, you can break that up and subdivide it into drawing basically lots of bitmaps to the screen. And for the image you can see here, actually, it's like a tile map where we have a number of 2D images that are available, and we can draw these at different locations, stitch them together, and actually let that combination build up how the world looks like. So whilst we are thinking about 2D rendering, basically what it means is drawing out lots of different bitmaps to the screen. Nothing really more than that. You can see there that positioned, scaled, rotated, tinted. There's different transformations that we may actually apply to those bitmaps, and again, but we'll see those in detail as we go through things. Little aside, you might think 2D drawing bitmaps, well, 3D. Actually, in 3D rendering, the basic notion of drawing bitmaps or screen-line quads is actually very common as well. So you have an example here where ostensibly we have a number of 3D models, but in terms of the foliage, sort of the bottom of the screen, these would actually be 2D planes that are orientated in a certain direction, and we simply draw a bitmap to those planes. Most of it's transparent, so you can get to see through it, and you can do shadowing and things from this. So even though 3D games is what most things have nowadays, there's actually still quite a lot of, in essence, 2D drawing bitmaps to this here, be it in terms of texturing or other forms of particle effects where that's still used. Okay, now an important thing in all of this here. So we're drawing things out to the screen. We want this to be fast. We want it to be as fast as it possibly can be. Quite often inside a game, the rendering and drawing your world to the screen is where a large clump of time is spent. And for various reasons, be it in terms of the graphical complexity or just simply not being efficient and preserving the battery on the device, because after all we're targeting mobile devices here, we want our rendering to be fast, hence efficient. And effectively that's what that means. So that's going to have very much an impact in the second part of this talk when we look at how we can do that, and then what are some of the consequences or implications in terms of how we code things. Crudely speaking, if we want to do things fast, Well, there's lots of different, again, massive area here in terms of optimization and different techniques that you can use. At the most simple level, you can say, right, okay, we're going to be running on a device. There'll be a lump of silicon that can process things. Some of that silicon is sort of described as the CPU in terms of being able to process generic instructions. Other bits, it will be the GPU, graphical processing unit, which is specialist hardware which is designed for actually transforming points, for drawing bitmaps or filling patterns and things like that. So in our game, we will want to make use of the GPU, and in doing that, we'll get a big performance increase, certainly compared to if we weren't using the GPU. So we want to use this to speed things up. We'll look very much more at that in the second part of the talk. Okay, so that's by way of introduction. Lots you can say about it. We're just concerned about 2D games. In particular, we're concerned about how we draw lots of bitmaps to the screen and how we draw lots of bitmaps nice and fast. That's our goal. If we can do that, we can do a 2D game. So let's have a look now in terms of Android rendering and the types of things that are available within Android for actually drawing out games to the screen. And I'm going to introduce some stuff here that you might sort of stumble across. First of all, if you're looking at Android, but it's almost by way of saying that the normal user interface components are not really what we want to do. We want to do things a different way. But we'll introduce, if you like, this to help again define a bit of context. Okay, so let's what I have here, if I get through to it, is, there we go. This is simply an empty application that was set up in Android Studio. So I created a new application. I just said, okay, create one with a simple fragment attached to it. So it's nothing more than this here. This is, we create a new one that says hello world. That's all you get. The reason I wanted to do this here is that whenever you're in design mode, you can get to see a list of all of the different elements that Android provides that you can actually use. And if you're creating an Android, you would normally say, well, okay, I want to add a button over here and I'll attach some logic to it and things like this. Now, if we think about this in terms of, right, we want to do a game, and you were clicking through the different things that are here, you might get down to widgets, and you would end up going, look, ooh, image view. So if I wanted to display an image, because it's a game, well, I could drag this on here. It'll ask me what type of image do I want to do. I could have an image available in the resources. I could bring the thing in. I could rescale it. I could size it, and other related things. Now, that's fine. That's a good way if you're doing a user-driven interface where you want to have an image that's displayed. It's not really appropriate for a game. So whenever we're thinking about doing a game, we want generally a world that evolves and changes quite smoothly, where the positions of things change, where it's quite interactive. So image view really in the Android app is more, if you've got an image, it's a bit static, you want to display it, that's what you can use. You can actually find a few other things down here. So you might sort of go down, texture view, is that relevant? You could drop that in. You could also find then a surface view. You could drop that in, and you might go, well, what on earth are those? Now, nice thing about Android, the documentation really is very good. So you can look these up. You can see for a texture view, can be used to display a content stream. Such a content stream can, for instance, be a video or an OpenGL scene. And we'll talk a little bit about OpenGL in the second part of this. So basically, they're saying here for a texture view, this is the type of thing that you can display images inside. It could be a video, it could be an OpenGL scene. Now, that's actually quite good. It says texture view can only be used in a hardware accelerated window. Again, that's quite good. So overall, not bad. It's a useful one. It's not the one we're going to be using. If we go to surface view then, and again, if you read this here, the description provides a dedicated drawing surface embedded inside a view hierarchy. So a dedicated drawing surface, okay, this sounds about right. This is the type of thing where we want to draw or game to the screen, and we want to control what exactly is drawn to it. So that's quite useful for doing a game. So you can control the format of the surface, and if you like its size, surface view takes care of placing the surface at the correct location. Okay, so again, that's also quite relevant. So go back to our app over here. There's different options that we have available. When we're thinking about GAGE, we actually keep this reasonably straightforward. So inside GAGE, we already said we're not going to have image views, we're not going to have buttons. Surface view, now you'll notice that a surface view actually is, if I add let's say I add a button back in, just an ordinary button. A surface view is not really a component per se, but I can attach it to an actual view object. So there I've attached the surface view to the button. And basically what I'm saying, as opposed to sort of the button normally being drawn, well, I can use my surface view for controlling what is drawn when the button is drawn. So if I wanted to have a completely bespoke button drawn in a completely different way with some fancy graphics, I could do that. Okay, so that's useful enough. Anyway, I'm going to delete them now because I want to talk about what GAGE uses for its basic setup. And what it uses, we go back here to or let's say, well, actually under widgets, we've got a view at the top. Now I'm going to drag a view in. View's quite large, more or less sized to be the whole bit. If we have a look at what a view is, we'll go back to our documentation. Yeah, and actually, so surface view, for example here, extends view. Texture view extends view. In fact, button extends view. Everything extends view inside Android. So view is the base class. So it represents the basic building block for user interface components. You can have lots of different types of ones. And we want to create our own custom view into which we will draw or game. If you're going down through the methods in this here, again, you can have a look at them. There's some for laying things out, but you have a drawing method, Ondraw, and we'll come back to that in a second. Okay, so over here, what I'm going to have is a view. Actually, I'll take out my hello world from this as well. So we've got a blink, nothing there. I'm going to add in a view. So this is a simple view, it's not of any particular type, and into that view, I will then add in a surface view. And I will link it to the view itself. So in essence, what I've done here is I've created my own view. I'm going to size it to be the same size as the screen because we want to occupy all of the screen. And I'm going to say it's really a type of surface view because I want to be able to control what is drawn to the view. I'll be drawing different bitmaps in different positions. If it were, for example, a main menu, I might have a nice animated background. I could draw some button style images on the screen. If it's my actual game itself, depending on what the game is, I'll be drawing other bitmaps at different locations for the game objects and the characters and the scores and things like that. But in essence, this is the simple framework that we are assuming within GAGE. Lots of different ways you can do it in Android Studio. This is the one setup we're going to use because it's simple, it's straightforward. It's not the best, and we'll talk about that in part 2, but it gets us going, and it's actually not bad at all. So just to reiterate, we will have our Android activity and fragment. Inside our fragment, we're going to have the view object that we'll create. It'll be big, it'll be the size of the screen, and that view really is going to be a type of surface view. Surface view meaning that we can control what is drawn to it, and we'll be drawing our game to it. Now, just add a bit more flesh on to this. If we go back to view and have a look at the Ondraw method, it says implement this to do your drawing. Perfect. That's the thing that we then want to add our own code into so that when we draw it, what we draw is what the world looks like at a particular point while playing the game. So a method will be overloaded. You can see that it actually takes in a canvas object. And canvas is a key Android class if you're dealing with graphics. So we can click through in this and we can have a bit of a read as to what a canvas is. So canvas holds the draw calls. So in essence, this is the thing that if we want to draw something to the view, we will use a canvas to do this. It will give us access to methods for drawing bitmaps and text and clipping it and doing lots of different things. To draw something, you'll need 4 basic components. And I'm going to go over these now because these will give you some of the key concepts to look out for when I show you some of the code. So in Android, if you want to draw something to a view object, 4 different things. You need to have a bitmap that holds the pixels. Okay, so we're going to have some bitmaps that will contain the images that we want to draw. We've got to have a canvas that actually deals or offers us the functionality then to draw onto the view object. And we get canvases really by default. Whenever Android wants to draw something onto a view, it'll say, well, I'm going to create a canvas and I'll give it to your particular method so you can make use of the methods on this to draw onto the view. So we'll get a canvas for free. Drawing primitive. This could be things like a rectangle or a path or a piece of text or indeed another bitmap itself. Now these we will use because when you say I want to draw a bitmap onto the screen, there's a few things you would want to be able to define. One is, for example, how big this bitmap's going to be. At what location do you want to draw it? And other related things. Do you want it to be rotated or not? So you can describe this in terms of how you actually draw things out. So we'll use rectangles quite a lot. We'll also use matrices too as our drawing primitive because that gives us more options about how we transform our bitmaps, but that'll be for a later talk. You also have a paint object. So paint object determines how exactly you draw the bitmap, basically how you transform the bits, the textile elements within your bitmap to transform how they're drawn onto the view and hence onto the screen itself. So you can use this here for applying color tints to bitmaps, or if you're drawing out some text, you can use this here for saying what font you should use, what font size you should use. Okay, so there's a fair amount of things here. Let's maybe just bring this together a little bit and we'll have a look at some code. Now, I'm only going to focus on this one method because in part 2 we'll delve into this in more detail when we have a look at threads and communication between them. But I just want to highlight that it shows these different elements coming together. So just by way of context here. So here we have it's going to be a surface view, and it's our own particular type of surface view. So that doesn't matter. All that matters is it's a surface view, and this is something that we're going to, is what our view is going to be. It's going to be a type of surface view where we control it. It means then that we will overload or have our doDraw method, which will be called whenever we need actually to paint on the screen, and we'll take in a canvas object to help us do the draw. So that'll be seen. And the canvas, you can get the width and the height of it if you want to. You can see down here we are, now it's not declared here, but if I go to the declaration of this, we are going to have a rectangle called mrect. We're going to have a paint called mpaint. We're going to have a bitmap called image. So these are the things that we seen in the last one. If we want to draw stuff out, we need bitmaps. I'm going to call it an image. We need a paint instance. We'll show you how that's used. And use a rectangle or a matrix or some other aspect. So we have these particular things defined. So inside our draw, what are we doing? Doesn't matter about the details here because we're really just interested in sort of the overall structure. But in these 4 lines here, we're defining the rectangle where we want to draw our bitmap to on the screen. So this will say, well, it starts over here and it goes down to there, and that's going to be the size of it. Brilliant. Here we are going to our canvas and we're saying we want to draw a bitmap, and we're saying here's the bitmap we want to draw. Now this actual parameter here is null, but what this parameter actually says is which bit of the bitmap do you want to draw. So I could pick a portion of it. If I say null, I'm saying I want to draw the whole bitmap. The next parameter says, well, where do you want to draw it to on the screen? And that's the rectangle I defined above. And the final one, which is the paint, can be null. If you say it's a null paint, if you're drawing out a bitmap, it just means don't manipulate the pixels, just draw them as they are. Keep the original colors. But if I wanted to apply a transform or a tint or an alpha value to it, I could create a paint for doing that. Don't do it here. So that's as simple. That will actually enable me to draw a bitmap out to the screen. There's another bit underneath. where I am going to my paint object. I'm setting the text size. I'm going to use the paint now to control how some text is drawn to the screen. I'm setting its aligned to the left. I'm setting the color to a particular color. And then I'm going to my canvas object, and I'm asking it now not to draw a bitmap, but to draw some text. I say text is this. I give the location of it, so 50 pixels across, 50 pixels down. And I say, here's how I want my text to be shaped and colored and positioned, as described through the paint object. So it's really quite straightforward. We have a little bit of setup or view. It's going to be a surface view. Basically a draw method will be called, where we have a canvas, and then using that we can control how images get to be drawn to the screen. I'll simply run this here so you get a bit of a feel as to what the thing does. This is over here. This is under our surface view test. If I run it, yeah, there you go. It's basically drawing one bitmap, which is that sort of colored square, at random locations, at random sizes. So each of the rectangles you see flashing up on the screen here is just a randomly created rectangle where we squeeze or extend the bitmap into that rectangle. The text at the bottom is sized, it's colored white, it's left justified, and it holds the text in terms of it actually counts up. Okay, so there we go. Just to round this off, and I was going to say, Android, you've got lots of built-in GUI elements inside Android. They're fantastic things if you're doing a lot of applications. We're doing a game, we're going to keep it simple view object, and we'll draw things to that view object. So we're ignoring most of the lovely GUI features that Android offers. Now, to bring this first part of this sort of explore into graphics to an end, just a few takeaways from what we've had a look at. Important thing to remember, the notion of rendering, of drawing, be it in 2D or 3D game, it's a very large, it's a very complex area, it's a fascinating area, but fundamentally, one of the things we want to do is to make sure we do it fast. Doesn't matter what we're doing, we want it to be fast. And that's going to be of relevance to the second part of this talk. Android, it gives us lots of different ways that we can draw things to the screen. If we wanted an image view, we could have that. We could just have a basic view. It could be a surface view. It could be a texture view. We could use OpenGL. We could do lots of different things, which again gives you flexibility. From our point of view, we're keeping it simple. We're going to have a single view object, which is going to be a type of surface view. And when we are drawing to that surface view, we're going to make use of bitmaps and paints and rectangles to draw out images to it. And for our game, we'll just make sure when we draw these images that they build up the game world that we have associated with our game. Simples. Okay, sorry, yes. Second part of this talk, we're going to look at some of the threading implications around doing this in Android. Have a look at how it's actually done to actually make this fast.